Hey y'all, welcome back to the lab. In this video, we're going to be talking about spinning up a Fullstack F web app in 10 minutes with the CloudSeed Project boilerplate. So I've just pushed some big changes to CloudSeed for its version 3 release, and it's been a while since my last CloudSeed Quick Start tutorial. So here I wanted to share an updated version, including all the new kinds of things that are in it, from technologies to simplifications and stuff like that. And so in this post, we'll walk through spinning up a Fullstack F web app in 10 minutes using CloudSeed and discuss its philosophy, how you actually interact with it, and some more details about how to actually build apps with it. All right, so let's start off with an overview. So CloudSeed is an F project boilerplate for building full stack web apps. CloudSeed's goal is to provide a seed from which to grow a simple, scalable web app with F#. It provides the core components needed for most web apps, a web framework, configuration, database upgrades, but avoids being too prescriptive so as to remain flexible for the majority of apps you might want to build. And previously, in previous versions, CloudSeed has contained a lot more features, things like payments and authentication and emails and all sorts of stuff like that I do see across a lot of other boilerplates, but in practice, what I found is a lot of people were, starting with it and then ripping out a bunch of the stuff because they wanted to build it themselves, which I think is fine. But with all those extra features, I started to kind of get the feeling that it was getting in the way more than it was allowing people to build quickly. And so I've since simplified this to be much more minimal so you can build whatever you want on it. And so here's the system architecture. Basically it's a modulith, which is a modular monolith with vertical slices. And so really all it is a web server that's running F# on Falco. All of this is containerized. It comes with a local Postgres development database, which we'll talk about in a second, also containerized for easy spin up on your local machine. And it's not prescriptive at all for what the front end is. Currently, the example domain that's ships with it just returns server-side rendered HTML. But obviously, once you have like a web server backend set up, you can do whatever you want on the front end, whether it's HTML or plugging in Vue or Svelte or React or whatever it is. So it gives you the seed, and then you can choose to grow it however you want. So like we talked about, the front end is really whatever you like. Really what CloudSeed is giving you is the backend web server with all the core components that you're going to need for basically any kind of app you want to build. And so you can build those endpoints to return data. This is very common in the form of like JSON or gRPC or whatever it is, or front end or markups if that's more your bag. And this is how I build things. Usually return HTML directly from the server with things like HTMX or DataStar in a more multi-page application kind of format. Now for the backend, it's F# and Falco on ASP.NET. Used to run Giraffe, but I've since moved over to Falco in the past year. And then for database, we use Postgres. It ships with Postgres. If you really want to use something else like MySQL or something, easy to rip it out or change it. The whole idea with vertical slices is that there's only a bit of shared infra to kind of get you moving quickly, but a lot of this stuff is confined to a single slice, so it should be pretty easy to add and change as you wish. For more on this, I have a lot of posts on these technologies, so you can read Build a Full Stack Web App with F# and Falco here to get more of an idea of how you might build something like this. Now for hosting, I use Docker containers for simple run anywhere development. This is the closest thing, simplest thing, most scalable thing I found for, if it runs on your machine, it can run on any machine with Docker installed. And since basically Docker can be run on any major OS, most clouds have Docker native as well. If you're choosing like serverless, it's pretty easy to add on a VPS. This is basically the only thing that I found that really fulfills the promise of build once, run anywhere. And so I just ship Docker directly because that's how I like to build. That's how I like to deploy things. It's a simple scalable system for doing that. And so I think it's worthwhile. Obviously, you can use CloudSeed without Docker, but kind of one of the big benefits of it is that it is cloud native and containerized already. And it does have its local development database that comes with it to help you with, local setup of an environment that actually mirrors prod, which kind of helps you avoid a lot of different problems that occur when you don't have local mirror prod. And so that's why it runs Docker. And I think that's something that will probably continue to be there unless new containerization paradigms come out. And so again, CloudSeed is a seed for your app. It is not a fully grown tree. Its goal really is to provide a simple, scalable foundation from which to build the app you want, trying to give you everything that you will need, but not give you anything that you'll have to rip out or anything like that. All right, running CloudSeed. So CloudSeed assumes that you have two things installed on your system. You need Docker to be able to run Docker containers and Docker Compose, which we use to orchestrate the dev containers together because we need to spin up our development database container and our web app and tell them how to talk to each other. Now, exact instructions on how to install this on your machine are out of scope of this, but you can check out the official Docker documentation. It should take less than 5 minutes to install both of these, and it works across all major OSs. So if you don't have that, go do that and install it before trying to run CloudSeed. And then to run CloudSeed locally, you only need one command. And it's this pretty long thing, but basically what it's going to do is it's going to spin up two services, a local development database, so you can build and test locally on an environment that actually mirrors prod, and the backend web app. And so I am going to demo this live. And so I'll just copy and paste this command, open up CloudSeed, we can see it here, and I'll paste it and we'll watch our Docker containers get spun up. So it's going to build stuff, it's going to start running. We see the development database up here starts running, or Postgres, and then we see our app start running. We can see it connecting to the database, start doing its upgrades, and then it says that it's starting to listen. So it seems to be running successfully. Now we can go hit it. And so it spins up these services, and I have a few endpoints and ports that are pre-configured. You can change these if you want, but I like having some pre-configured ports so you can actually make sure it's doing what it's supposed to do, and then you can kind of get an idea of how you can extend this. So 5001, this is just the index. To start, it just returns raw text. So you can see that it's actually working. Obviously, when you actually start building your thing, you'll hopefully have something on your index that's different than this, but this is the pre-configured one. I also provide a few health check endpoints. These are often frequently what you want when deploying, just to make sure that is it an app problem or is it a configuration problem or what is it? This one basically just returns raw text at /healthweb, and then we have /healthdb that is actually pulling and adding directly to the database. So if you want to debug those kinds of problems. Here what we're doing is basically every time you hit it, we create a new kind of sentinel item in our database, and then we just return everything, just so you know that this stuff is working. And then finally, I include an example end-to-end web app. This is running Falco and just returning server-side rendered HTML, just to kind of give you an idea of how you might build your own vertical slice with this architecture. And really all it is that same HealthDB endpoint and database, these sentinels, but we've just included some more styling and stuff, so you can get an idea of how you might turn that into a full, UI. And then of course we have our local database, just located at port 5002, in case you want to interact with it directly or something like that. And of course, no production app is complete without tests, and so we do have a pre-configured testing project, so you can run with another command. Again, what this is going to do is spin up a local development database. It is going to be using that same Postgres database so that you can catch any configuration issues or anything that's directly to do with Postgres, which does happen sometimes. And then it just runs the tests against those. So we'll grab this, come back over to our code base, shut down our Docker containers, run our tests, and it runs. And it sees as passed, failed 0, passed 3, and so that's all good. Now, there is a valid complaint against this, local dev tools with .NET for debugging and running tests are much easier because you can choose the given tests and stuff, and I think that's totally valid. And so if you want to run that stuff without Docker containers, that's fine. But one of the things I really love about doing Docker containers is if you're running a CI or build system, you can literally test locally the same way it will be in CI. Again, making sure that you are mirroring dev and prod, which basically cuts out a whole class of issues that can occur just from environments not being the same. But that is a fair, concern. And so, if you're using CloudSeed and you really want to see better local dev tools, let me know and we can work on that. All right, on to the code walkthrough. So we really can't cover all the code in a 10-minute walkthrough, and we're already over the 10-minute mark, and so we're not going to do that. But I am going to give a quick survey of some of the most important bits of the code base and kind of what they're for and why they're important. And hopefully this gives you a jumping off point if you're new to the code base. If you are confused about anything, if you do want more deep dives into one of these, just let me know. Happy to make them. But in general, like deep dives into like a random code base without context is not useful to most people. So I'll probably wait till someone asks me. Okay, so the most important thing is probably program.fs. This is the app's like root or main. And so really is like the composition root of all of the vertical slices and how we hook them up into the core ASP.NET so they're actually serving something. And so this is going to do things like spin up ASP.NET. We're going to pull in any configuration files. We're going to upgrade our database. We're going to build our services and inject any dependencies that they need. And then we're going to configure the Falco web framework with all the endpoints so that it can actually route to the correct place. And so here we can see in our program.fs, we have this build routes thing. It's going to create our service context, which is basically our dependencies. Then we're going to create our list of endpoints. We've got our health checks here. You can see how they actually interact or hooked up to the endpoints, how they actually do their functionality. And then we are composing all of our vertical slices here. And so it's a pretty modular approach where each vertical slice can determine what its own dependencies are, what all of its endpoints are, and then all you have to do is hook them back up over here so that you've composed them all together. Configuration.fs handles reading in the app configuration based on the environment. Really all this is doing is saying like what are the values we expect from the app environment, and then we just, depending on the environment, actually read them in from the appropriate JSON file using app settings. www is where you can store any static files you want to serve with your web app. You can see this in app/www here. I just have an app.css here. If you are familiar with ASP.NET, this is basically the standard place to do that. In infrastructure, we hold like shared infra across the app. Again, this is like a vertical slice architecture, and so we're really trying to minimize the amount of prescriptions we're making on how to do things. But I do think that database upgrades are like pretty important across everything, and I am a little opinionated on how to do these. And so currently, basically, the main thing it has in it is its dbup configuration, which you can upgrade scripts and database upgrade scripts. So I've got a few helpers for persistence and presentation, but really it's these db upgrade scripts using dbup. That's most likely what you'll be interacting with. And then finally, I have the Sentinels vertical slice, which is like an example vertical slice so you can see how I like to build domains. You really don't have to build this way if you don't want to, but you know, CloudSeed is built around the best practices that I've found building web apps. And so I wanted to provide an example of this so you can really see like, okay, how would I build a web app? How would I structure my domain if I'm using this actual framework? And so that's what it tries to provide. And so the Sentinel domain itself is really made up of 3 files. I think if you have, you know, a sufficiently large amount of code, you might split these up further, maybe into about 6 files. But in general, what I found is F# can often do long files much safer than other languages can because it does enforce explicit hierarchies. So you have to define the thing before you use the thing. And so in my experience, a lot of the times you can get away with much longer files. And so this actually reduces the file overhead without sacrificing like robustness or correctness. And so that's what I've tried to show off here. And so the main file is Sentinel domain, and this is going to contain the domain models followed by persistence. I'm using Entity Framework here for database access. I know a lot of people, you know, think of the onion architecture and like kind of want to push persistence down to like the lowest level because it's like a shared dependency. And I think this is like not wrong, but in practice, you almost always are going to need to, in all your workflows, rely on the domain models that make up your domain and the repos to actually get at the core data. And so Entity Framework tries to be that repo. And so I'm just passing it raw here and defining it up top because I know I'm going to pass it through a lot of things. And it seems to work pretty decently, but you know, you don't have to follow this kind of hierarchy if you don't want to. So here we got the Sentinel domain. We just got all of our types. I like the types to be in their own module because then you can pass this around without any kind of like implementation details. Really good for making sure that you're only coding to the, you know, actual interfaces, if you will. And then we've got the actual persistence below it. So this references the types, but pretty clear separation here because this is really implementation of the repo here. Next, we got the Sentinel service. This is containing like things like the workflow or service functions for the domain. I just have this on like a loose CQRS pattern here so that you can kind of see this in action if you approach that. Although personally, I'm kind of straying away from the whole idea of CQRS. I think that just domain workflows are really just more accurate for what you want to do. but I've just left it here because I didn't really have a reason to change it. And so you can see that here, we've got our Sentinel queries, things that are not, making updates to the domain, and we got our commands, things that are, which is really just to create. And we can see that we're using our service context, which is how we're actually doing dependency injection. And as part of that, we pass in our DB context. And so that's how we're actually accessing the data. And this is an example of why I do think it's important to, if you're not going to go all interface heavy, just define your persistence, or at least its types early, because you're going to use that throughout the rest of the app. Finally, we got our Sentinel presentation. This is containing, our server-side rendered HTML code and exposes a list of endpoints to be consumed by the app's composition root in program.fs. And so this is an example of one that, pretty quickly you probably would want to split up into a file, like maybe Sentinel views, and then you have presentation. But basically, we got my main page views stuff here, and I'm creating markup with falco.markup, which is an HTML DSL. Give me some type-safe HTML, which I like. So we got all that, and then we have our HTTP handler for this page. And then down at the bottom, we have Sentinel endpoints. And so here, we're mapping /sentinels to the actual HTTP handler to create this. And you hopefully can see how this is pretty composable, where as I add more endpoints, I can just pawn it off to wherever that handler is. And then you can code that handler however you want with whatever logic you want. And of course, you can do API endpoints here as well if that's what you want to do. And this is kind of where the composition root happens. It passes in the service context for the whole service, and then we pass it into a Meech handler, which is how we do basic lean dependency injection. Now I want to note that the Sentinels module is intentionally simplistic, and it's built to showcase various usages of CloudSeed's core components while being very easy to rip out when you no longer need it. And so this might be too simple for use case, it might be overly complex, leaning on some things that you don't care about. All of that's fine. Really, it's just a showcase. You do not have to build it this way, but this is just an example of how I like to structure my projects, at least at the start, so we're not in analysis paralysis of how to actually structure a project. Next. Now, that's a quick and dirty overview of CloudSeed, my F# WebApp boilerplate that I use to start most of my projects. This is how I like to build web apps, but the approach and tools and technologies won't be everyone's cup of tea, and that's totally okay. One of the beauties of coding and building stuff is whatever you can imagine you can build. Everyone's imaginations are different, and so this is just how I like to build, but you really don't have to if you don't want to. Now, if you like this post, you might also like the HAM stack, a simple scalable tech stack for building modern web apps fast and cheap. This is more of the philosophy of how I think most apps should be built for the web. You might also be interested in some more implementation guides, like build a single file web API with F# and Falco, which is more about setting up endpoints, getting to know Falco a bit, and then complementary to that is build a full stack web app with F# and Falco, which goes more into server-side rendered HTML and how you can basically turn these backend web APIs into very feature-rich front ends without changing too much. So that's it for this video. Thanks for watching, and I'll see you in the next one.